Alrighty, wonderful children. We're going to do an awesome Chapter 5 review video. I mean, these review videos have been a viral hit. I've been all over the news these days. Not really, just kidding. All right, but like 100 people watched it. That's pretty cool. So we're going to continue with these because it seems to be helpful for some of you. Anywho, all right. Let's just hop to it. We're going to start with all no calculator problems, okay? There's going to be a couple calculator problems that we'll do, but the majority of this is going to be non-calculator. Unless I bust out that TI-84 emulator, it's going to be non-calculator. Cool? Awesome. We're going to rip the Band-Aid off. We're going to do long division right off the bat, okay? So let's say we are doing x plus 3. We're going to divide by x plus 3. And then let's go with a 4x cubed minus 5x plus, wait, let's do squared, 6x minus 1. Okay, boom, wonderful. If you want to try it, pause it, hit play, see it worked out. Your call. This is your video, however you want to watch it. Okay, lovely. Ooh, can't do green because then we have green and yellow, and the Packers are lame. All right, 4x cubed divided by x gives me 4x squared. Lovely. Okay. Now, from here, I'm going to erase that real quick. I'm going to multiply it to both of these and write it down below. So I'm going to have 4x cubed plus 12x squared. Okay? Then I'm going to be subtracting. So I like to do this nice little rhyme. Draw my line, change the sign. That way, now I'm just adding them together. Okay? So I've taken care of the subtraction aspect. Those are going to cancel. They always will cancel. And I have negative 17x squared. Coolio. That's it. First step. Hold up. Snoop Dogg. Drive it like it's hot. Okay. Good stuff. Fantastic. Yes, I'm in the garage here today. Jenny's inside hanging with Aubrey. So, no Jenny right now. But maybe I'll bust her out. Bring her, have her see if she'll come in and visit during some math here in a little bit. All right, let's continue this problem and not babble so much. Sorry. Long day. So now, negative 17x squared. If I do that, let me do a slightly different color here. Whoop, whoop, divided by x, I'm going to end up with negative 17x. And then I'm going to, once again, multiply to this and to this. So I'm going to have negative 17x squared. And then I'm going to have, oh boy, these numbers are getting large. Let's see here. That'd be what, 51? Yeah. So negative 51x. All right. Lovely, lovely. Cool. Draw my line. Change the sign because I'm going to be subtracting, right? So that takes care of the subtraction aspect. That's gone. And I'm left with 56x. Cool. Awesome sauce. Awesome sauce. Drop my negative 1, and I'm ready to do it again. Cool. Let's keep going. All right. I'm going to switch to, I'll go with pink. All right. So now I'm doing 56x divided by x, and I'm going to have positive 56, and then I'm going to multiply through. The number's going to be this large on a non-calc, but, we can handle this. Believe me. 56x. And then, because I'm multiplying, let me get these lines out. I'm multiplying to the x and then also to this 3. So, wait. There we go. My apologies. Let me rewrite that so it's actually legible. 56x. Okay. 56 times 3. Well, 50 times 3 is 150. 6 times 3 is 18. So 166. Draw my line. Subtract. Or change the sign, and I get negative 160. My gosh, okay, 67. Negative 167. That's my remainder. So my final answer here is going to be 4x squared minus 17x plus 56 minus 167 over x plus 3. Or you could do plus and then negative 167 over x plus 3. I prefer this, so that's the way I'm going to do it. But that'd be my final answer there. Wonderful. The numbers would stay smaller on a non-calculated portion, but I just made these up on the fly. All right, for this next one here. So graph the polynomial function with roots 0, negative 5, and 7, and write an equation in factored form. And I'm going to throw a little twist here, okay? A little twist. We're going to do this 2 different versions. with a positive lead coefficient, and we'll do one with a negative lead coefficient. Okay, so we're going to do this problem in two different ways because there's two different scenarios here. All right, so we can see all of our roots. That's good. So in yellow, we'll go with our positive leading coefficient. So if I were to graph this, I have at negative 5, 1, 2, 3, 4, 5, at 0, and at 1, 2, 3, 4, 5, 6, 7. Okay, so those are my roots. Now, this is a cubic function, degree of 3, so it's going to be that like just single little n kind of a shape. And if it's a positive leading coefficient, it'll look something like that. Cool. Awesome. Now, my equation in factored form will be, well, if 0 is one of them, I'll just put x. Then I'd have x plus 5 and x minus 7. And that would be my factored form, integer, coefficients, all that good. All right, now let's go with the negative leading coefficient. Let's do it. So let's see here. For my graph, again, same zeros. 1, 2, 3, 4, 5 at 0. And then 1, 2, 3, 4, 5, 6, 7. Beautiful. But this time, my end behavior is going to change, right? This thing's going to flip. So I'm going to be coming from up here through this and back down. So it's going to finish going down and to the right when it's negative. Now, my equation will look the same, y equals, but it's going to be negative. And then I will have x, and then x plus 5, x minus 7. That's it. Cool? So if we ask for a positive lead coefficient or a negative lead coefficient, you'd be able to handle either one of them. If you could do this one right here, that's dope. Let's keep going. All right. I didn't write any actual directions down. I'm just going to verbalize them here. What we're going to say are how many real and how many complex solutions we have here. Okay? So for each one, it's going to be real, complex. All right? So for this first one here, that is a cubic function that we can tell. Right? That's the minimum degree that we know that it at least is. I see it crossing the x-axis 3 times, so 3 and 0 complex. So since we know it's a cubic, that would have 3 possible solutions. We can see all 3. There we go. All right, next one, real complex. So for this one, I can see that it's a quartic function, a degree of 4. So there should be 4 total solutions. I only see 2 of them, 2 reals. And then we have then left over 2 complex solutions. Lovely, fantastic, wonderful. All right, next one. What the heck is this? All right, I know what it is. I made it. All right, the camera's not down here, so sometimes I look at myself. I should put myself like way up top. Uh-oh, okay, good. I didn't do anything. I should put myself up. Oh, that's fun. I like that. Now I'll actually look at that when I'm up. Okay. All right. So for this one, I have, let's see here. This portion here would be quartic, right? But then it comes back up and down again. So this is a degree of 6 here. Okay, this is a degree of 6. So I should have 6 real solutions. Well, I have 1, 2, 3, 4 that I can actually see it crossing. Why did I put complex and real backwards? Sorry. 4 real, and then I have 2 complex. Cool? Awesome. Lovely. Fantastic. Wonderful. All right. So, cool. I knew that was an even degree polynomial, right? Because they're both going down, right? If they're both going down or both going up, it's an even degree polynomial. That was beyond quartic. That bad boy is a degree of 6. Whew. Okay. Now, the orange one. Real, complex. All right, so for the reals, I see this thing. This is cubic again, right? Degree of 3, so there should be 3 total. Now, I see it hitting or crossing the x-axis twice, but what's happening here? That is a multiplicity of 2. It counts as 2 solutions, and then we have our third one right over here, so there's 3 real, 0 complex. You will never have 1 complex solution or 3 complex solutions. They always come in pairs. You can never have just 1 complex solution or 3 complex solutions, or 5 complex solutions. It's either 0, 2, 4, 6, 8. Who do you appreciate? Mr. Allen for making this video. So 3 reals, 0 complex, never a single complex solution, okay? Our complex solutions come from negatives being in our square roots, which whenever we're solving and we use square roots or quadratic formula, we have plus or minus that square root. So plus or minus some imaginary number, you're going to have 2 of them, okay? Cool, awesome, fantastic, wonderful. All right, last one here, and then I want to discuss one other thing with these particular problems. All right, so real, complex. Well, here I have a degree of 5, right? It's beyond a cubic. It's got one more, and it is different on each end there, right? This is a negative degree of 5 here. Negative quintic polynomial. Awesome. All right, so my reals, well, I see it crossing once, but bouncing twice. 2, 1, 2. That's 5 total, right? 2 solutions here, 1 solution here, 2 solutions here. That's 5 real, and once again, 0 complex for this one here. Awesome. Next thing that I want to talk about. If I said, how many distinct real solutions do I have? I have 3 distinct real solutions here in the blue one. I have 2 distinct real solutions in the green one. I have 1, 2, 3, 4 distinct real solutions in this pink one, but these bottom ones here, I have 2 distinct real solutions. It bounces here, so that's like, let's say that was -2 or something like that. That's repeating. That's not a distinct solution. It's the same solution just twice. Okay, so this would be 2 distinct reals, 3 total. And over here, same kind of idea. I have 1, 2, 3 distinct real solutions. Unique would be another word that might, jive a little better with you. But that is a word that we could throw out at you on a test, or an SAT could throw out. They love those kind of words, distinct or respective, which is totally different, by the way. But they do like using that kind of vocabulary. All right, enough with that. Moving on. All right, so given this polynomial, the graph of this polynomial equation here, we're going to find our max, mins, intervals of increasing, decreasing, and behavior. Okay? We'll write an equation from a graph later on where they're all nice little things. Or maybe we'll just decide to do it. I don't know. All right, maximums. So I only have 1 local maximum here. It is right here. It looks to be at, and it would be clear on a graph on a test, it looks to be at 2, 2. And I'm going to go ahead and jot that down on there as well on the graph. All right. And then I have a minimum at 1, 2. So -2, and then 1, 2, 3, 4, 5. -2, -5. And then over here, I'm at 1, 2, 3, 4, down 2. Now, you might be thinking like, oh, wait, but the -5, doesn't that like supersede it, right? It's more minimum-y than the other one. These are local minimums, okay? So we're going to list both, any low points, okay, or any high points for local mins and maxes. All right, cool. We got our mins and maxes. Now let's go with increasing and decreasing. So it is decreasing. I'm going down, yelling timber, on that stretch, so from -infinity to -2. The x value, right? The y value isn't part of this whole telling me where it's happening. I'm talking about horizontally, where is it going up and down? Then it's also going down on that stretch, right? We think of this as like if you were on like a roller coaster, the polynomial roller coaster, okay? A lot of ups and downs, right? Just like life, children. Just like life. Got some ups and downs, Now we're philosophizing. All righty. I'm going to change colors for going up. Whee! Blue seems happier than yellow. So I have from -2 to +2. And then I'm going up again right here from, okay, we're good. Awesome. I thought I made a mistake. I'm going from 4 to +infinity. That's awesome. It's dope. It's wonderful. Fantastic. All right. Are we ready for some end behavior? I believe so. End behavior here. All right. We can stay in blue. You know what? I'm going to switch to green. Okay. Favorite color. All righty. As x approaches +infinity, what is f of x approaching? Well, as I'm going to the right, hopefully this looks right. I'm talking about this side of the graph here, right? As I'm going to the right, I'm going up. I'm going to infinity. As I'm going to the left side of the graph, I was about to draw a backwards arrow. As I'm going to -infinity, f of x is still going to +infinity. It's still going up. It's going up on both sides. All right. The increasing and decreasing does not affect the end behavior here. Okay, those are totally different things. Sometimes they're the same looking, but they're not at all related. Okay, cool, awesome, fantastic, wonderful. I said that a lot. That's okay. I don't care. All right, moving on. All right, we're going to write the equation of the polynomial in factored form given this graph. Okay, now let's see here. What do we need to write the equation in factored form? So that's like the easier. We don't have to multiply it all out, right? That's kind of nice. So let's go ahead and let's see here. I got zeros at -3 and at +2, but there's something special about -3 is that's a multiplicity of 2. Okay, so when I write this out, I have y equals, and then I'm going to have x plus 3 squared, and then I'll have x minus 2. Those are my two factors. Now there's also that little a out front. Okay, so this is fun. This is great stuff. Well, how am I going to figure that out? Well, I do notice my scaling on the y-axis that this would be the point 0, 6, right? So I know of another point that is on this polynomial function, right? On this graph of this polynomial function, rather. Well, what if I plugged in 0 for my x's and 6 for my y's, and I solved for a? Let's see what happens. All right, so just like when you're setting it for like y equals mx plus b, and you plug in your x and your y, and you have your slope already, you solve for your y-intercept, it's kind of like that, same process. So if I plug in 6 for y, I got a, and then I get 0 for x. I'll show all my work here. So I'm going to have 6 equals a, then it's 3 squared, and then -2. 3 squared is 9, so then that's going to be -18. Divide by that, and I'll get a equals -1/3 when I simplify. 6 divided by -18 is -1/3. Okay? So now my final answer here is going to be y equals -1/3 x plus 3 squared x minus 2. I got to have that a there. Notice how it's also negative. Like it works itself out into being that negative. Again, I don't know if I'm mirrored or not. Sorry. It works out to be that negative cubic function. It already takes care of it. We knew that was going to be negative because it's going down and to the right. We're good to go. Cool? I love it. That's fantastic. All right, how about this? What is the end behavior of this polynomial function? And again, we are on the non-calc, so I would need to know what this graph looks like, kind of. Okay? Well, what degree is this? Let's first start with that, because if we know the degree, we can figure out the general shape, and from there we can get our end behavior. The degree here is 4, right? How the heck did I get that? Well, this is a degree of 1, that's a degree of 1, but then we have degree of 2. 1, 2, 3, 4. Put them all together. Okay, so if I were to multiply this all out, terrible, right? But I would get a degree of 4. So I know, and it's positive out front, that it will have some kind of a general shape like that, right? It might not be quite as drastic, but it's going to be going up on both sides. So as x approaches infinity, f of x approaches infinity, and as x approaches negative infinity, f of x approaches negative infinity. Whoa, positive infinity. Ah! Sorry. So they're both going to positive infinity on each side. Cool? Super cool. All right. Another question, just a random one that came to mind here. What would my y-intercept be? Because there's a lot of math you could possibly have to do if you want to figure that out. I personally don't want to do that. As much as I love math, I will try to avoid doing extra math just because, time is important, right? Time is money. So y-intercept, question mark, double question mark. Well, for my y-intercept, my x value is going to be 0. If it's crossing the y-axis, my x value is 0. So I plug 0 in for all my x's, and I am showing all this wonderful work just for you, children. Well, that's gone, that's out. So I've got really 1 times -3 times 1 squared. Well, 1 squared is 1 times 1 times -3, so I'm going to end up with negative 3. So my y-intercept is 0, comma, negative 3. All I need to do is really I'm looking at this guy, that guy, and this guy squared. So if that was like a 2 being squared, you'd have to make that a 4, right? But 1 squared is just 1. Okay? Cool. Awesome. That was a fun question. It was super fun. So much fun. I love those fun ones. Couple exponent problems. Oh, did you forget that we had exponents in this chapter? Me too. Just kidding. I remembered. That's what we're doing then. All right. I like to simplify the inside first for this left one. So I'm going to do that because I'm the one doing the problem. So I'm going to do what I want to do. Okay? So deal with it. All right. So I got 1/3, right? 3 divided by 9 is 1/3. Simplified. Big numbers. The coefficients still follow our normal math rules. These are all still the same math rules. But when we're dealing with our like bases with exponents, when we're dividing, our exponents subtract, and I get x cubed up in that numerator. Then I have negative 3 minus 7. That's negative 10. To make that positive, pop it down to the denominator. Now I have 10 minus 2 is 8. So that will stay up in the numerator. We are all Gucci inside this wonderful set of parentheses here. It's time to deal with that outside exponent. 1 squared is just 1. I'm not even going to write that anymore. I'm going to have x to the 6th, z to the 16th, because I'm multiplying. 3 times 2 is 6. 8 times 2 is 16. And then I'm going to have 3 squared, which is 9. Okay? Not 3 times 2. 3 is not an exponent. It's 3 to the 1st, so now we have 3 to the 2nd. And then I have y to the 20th. Don't make that mistake of the coefficient. That is the most common mistake to make in this situation. Cool? Most common mistake to make. That rhymes. That's super fly. All right. Now, with this one, you got a couple options. I think what might work well is I'm going to create a fraction here. Even though that sounds like a terrible idea, like, oh, this will work well, I'm going to make a fraction. But what happens now is this is all to the positive first, right? So really, I can just get rid of that, okay? Now, up in the numerator, everything in the parentheses there is simplified. I can't do anything with that, so I got to distribute in that exponent. So I'm going to get 4x squared y to the 8th over 3x squared y. My x squareds cancel, and I'm left with 4y to the 8th over, not 8th, to the 7th. 8 minus 1 is 7, all over 3. Awesome sauce. Cool. All right. Lovely, lovely. Cool, wonderful, fantastic. All right. If x equals 1 is a root of that polynomial function, find all other roots. How the heck do I do this? Well, I need to divide the factor x minus 1 out of that polynomial. I'm going to use synthetic division to do that because I find that to be far more efficient. And I mean, that's just what we've been doing too. So I'll put 1 in the box there. Some people set this up differently. Sorry if your teacher does it a little different. Everybody has their own little setups. This is my setup, and I'm the best. So deal with it. I'm just kidding. If you like to do your setup, that's fine too. I've seen people doing like this, but this is what I do. All right, this is how I was raised, okay? So you get 1, 1, 3, and negative 5. If you have a missing term, make sure you pop a 0 in there. Don't forget that. Drop my 1. 1 times 1 is 1. That's 2. This is going to be 2 here, because 1 times 2 is 2, which equals 5. 5 here, 0. I should get 0 for my remainder here because x equals 1 is a root. If you don't get 0, you did something wrong. Go find your mistake. This isn't asking, is x equals 1 a root, or is x minus 1 a factor? It's telling you that it is, okay? If the problem was, is this a root? Then your answer would be yes. If you get a remainder that is anything but 0, then it is not, okay? I don't know if we'll do one of those problems, but we'll see. Kind of tired of doing math today. I know, weird to say. Tired of doing math today. It's 5 o'clock, okay? And I'm going ham on some math. All righty. X squared plus 2x plus 5. I want to set this equal to 0 and solve. My go-to method, factoring. Can it be factored? No. That's a bummer because guess what I get to use now? Quadratic formula. All righty. So opposite of b, x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. I'm going to get negative 2 plus or minus 4 minus 20. So we get negative 16 all over 2. Coolio, coolio. So I get negative 2 plus or minus, well, the square root of negative 16 is 4i over 2. Everything here is divisible by 2. So I get negative 1 plus or minus 2i. That is it. It asks to find the remaining roots. Those are my remaining roots. I don't even need to state the one that was in the problem because it just said find the remaining roots. If you wanted to put the x equals 1 in there, that's fine. But here, it just asked me to find the remaining roots. Okay? Awesome. All right. For what value of k is x minus 1 a factor of x squared minus 5x cubed, weird, plus kx minus 6. This is not currently in standard form, is it? I'm gonna write that. I'm gonna change it right now. Okay. I've made that mistake before. I 100% made that mistake on a key, and I got called out for that one. Okay, I messed that up. And I was told. So I'm not making that mistake again. Well, I might. I don't know. All right, so now I have it in standard form. I want to figure out what k is. So I want to know for what value of k is x minus 1 a factor. Well, if x minus 1 is going to be a factor, that means that if I were to either do synthetic division with 1 in the box, or if I were to do direct substitution with 1, I would get 0. So whether you choose to go the direct substitution route or the synthetic division route, either one is okay. I will show you both, all right? Because I'm just a generous person. So if I put 1 in the box, then I'm going to have negative 5, positive 1, k, and negative 6. Keep in mind, I want my remainder to be 0 in order for this to be a factor, okay? I'm going to drop the negative 5. I get negative 5 here. Add them, I get negative 4. Multiply, I get negative 4. Add these, it's k minus 4. Multiply, it's still k minus 4. And then my remainder is k minus 10. I want this remainder to be 0. So here I would get k equals 10. That is scary that it worked out so nicely because these are totally random numbers. But that's cool. I guess it worked out well because I have a 1 in the bottom. Never mind. This is math. This is math thinking. Okay? Don't worry about it. All righty. Cool. So we get k equals 10. Now the other method that I was talking about that I was referring to, let's take a look at that. Can't use green because then, Packer colors don't want that. All right. If I were just to directly substitute in 1, I'd have negative 5, 1 cubed, plus 1 squared, plus k times 1 minus 6, and that needs to equal 0. The remainder is the same as what it will equal with direct substitution, right? Sometimes we refer to it as synthetic substitution when we were just going for the remainder. So I'm going to have negative 5 plus 1 plus k minus 6 equals 0. I'm going to have k minus 10 equals 0, so k equals 10. Either way, I get the same thing. You're calling what you want to do. Okay? Some people synthetic substitution, synthetic division seems to work out best. Others, direct substitution makes more sense. I do not care. Okay? Either one's fine. I do need to see that work though. All righty. Let's keep going. Let's keep rolling. This is awesome stuff. Sorry I haven't brought Jenny in here. Again, chilling in the garage. She's hanging inside. I mean, we got cool dumbbell rack. That's really about it. Other stuff and things, but hanging out, get a pump later. You know what I'm saying? Right? Study hard, lift heavy. Okay? I'm losing it, guys. I got to stop making this video. I need to take a break from math. Okay. I got like maybe 2 more. All right. For this next one here, find all zeros using a graphing, synthetic division, factoring, and America. Okay, let's see what we can do this here. So I plugged it in my TI-84. I don't want to bring up the emulator. I'm worried that I don't want things to go haywire here. Okay, I don't want to jinx it. Knock on wood. Yes, I made a makeshift desk on 2 stools right now to do this in my garage so it can be quiet and stuff. Anyways, hello. I have my calculator here. Hopefully we can kind of see it. You can I'm sorry, it's kind of terrible. But it's a little better. Anyways, I can see it crossing at 2 spots here. All right, and those 2 spots are at -1 and at +3. So I'm going to use synthetic division twice to divide that out. All right? It's going to be awesome. And there we go. Whoop. Gotta go back up here. Kind of like this spot. Spot's nice. All right. So I'm going to go ahead and divide those out. It does not matter what order I do that in. If I start with the -1 or with the +3, your call. Just start with 1. I'm going to go with -1. And then I have my coefficients. -1, -8, deuce, deuce, -8 again, and -39. Drop the 1. We're going to work. We're going to do work, right? We should get a remainder of 0. So if we make a mistake, we'll know, right? I get -1. That's -9. 9. That's going to be 31. Then I have -31. And then I've got -39 times -1 is 39. 0 is my remainder. Awesome. Dope. Fantastic. Now I'm going to divide out the other one that I saw, which was 3. So I can just start right from here. Drop the 1. I'm not going to divide it out of the original. I'm going to continue to divide it out of the one that I'm dividing out of, right? I'm factoring these roots out, right? I'm taking out x plus 1 as a factor. I'm taking out x minus 3 as a factor, right? And to do that, I use their roots in the box in synthetic division. Awesomeness. All right. 3, that's -6. Now that's -18. Let me get 13. Then I get 39, positive 39. That's a remainder of 0. Woo! Now I've got x squared minus 6x plus 13, right? It's a remainder, then constant, then x, and then x squared. Again, I'm not sure if the way I go is left and right as I see it. I'm going to have to ask one of you guys. We'll answer that question after this video. All right, that equals 0 if I'm going to solve for the remaining 2 zeros, right? The remaining 2 roots. Whew. Nothing multiplies to 13 and -6. That's a bummer. I got to use quadratic formula again. Oh, bro, it just keeps coming back. Opposite of b would be +6 plus or minus the square root of b squared minus 4 times a times c. Square root of, I had a college professor, and he liked to say, square root of. He sounded like Count Dracula every time he said it, and it was awesome. I looked forward to square roots in that class. All right, over 2a. I think I should bring that back. Cool. Awesome. All right. Mike just finished a workout. Cool. Rings and things. Okay. 6 plus or minus the square root of, and I've got 36 plus, and this is the calculator portion, but, plus 52, right? 36 plus 52 is 98. Yeah. No, 88. Okay. The brain is tired here, guys. The brain is tired here. And it is definitely tired because that is wrong. I'm gonna show some work, like when I yell at you guys like, show work, you're making dumb mistakes. All right. All over 2. So that's gonna be 6 plus or minus, and that's gonna be -16, right? Coolio. I love it. Awesome. Fantastic. I feel like we had -16 underneath the radical before, but hey, it happens. This one's a little different though. All right, so now I've got equals, and then 6 plus or minus 4i over 2. So that's going to be 3 plus or minus 2i. All right. My finals. X equals, that is a terrible x. We had -1, +3, and 3 plus or minus 2i. I would need to write all 4 of those on my answer line. Cool? Awesome. That is wonderfully fantastic. Excellent. All right. Next thing, I think we should write a polynomial in both factored and standard form, but let's deal with some complex roots here. Let's say, I'll write some direction. All right, write the polynomial in factored and standard form with integer coefficients with zeros at -3i and 3/4. Well, if -3i is a 0, I do believe that +3i is also a 0. Side note, real quick, while I'm thinking of it. If 5 minus 7i was a 0, what would my other 0, my other root be? 5 plus 7i, right? If I had -3 plus 2i is one of my roots, -3 minus 2i would be another one. Okay, it's the imaginary that changes Awesome. Not related to this one, but I was thinking of it. Now let's get back to it. My apologies for the sidebar. All right. Cool. I hope that the audio and the writing are synced up. It has been an issue in the past. Let's do this. So I'm going to have y equals, let's see here. We're going to have x minus 3i. Ooh, no, minus negative 3i, which would be plus 3i. Then I have x minus 3i. And the last one here, we got to do a little bit of thinking. I'm going to need 4x minus 3, because if I added 3 and divided by 4, I'd get 3/4. There we go. Now, because it says integer coefficients, or could say like with only real numbers, I do need to multiply this first one out. I'm going to have x squared, and then I'm going to have minus 9i squared. So that would be x squared plus 9. And then we have 4x minus 3. Cool? Now, some of you, I know you might see that done a little bit differently, finding the x squared plus 9. If you did that differently in that, you're like, what are you doing? It's okay. There are other ways of doing this. This is the way I showed my wonderful children. So that's what I'm going to do in my video. All right. That would be my factored form. Factored form. Whoop. Now into standard form. Cool? Not green. Boo, Packers. I'm going to go light blue again. Okay. So now I'm going to have 4x cubed. And then I'd have negative 3x squared. I'm just foiling right now. And then we got 36x and then minus 27. Yeah. And that's all in standard form, descending order, right? We're good to go there. No combining like terms. That one wasn't too bad. All right. Last little bit here. Solve for all zeros or roots or whatever. Okay, let's see. We got x squared. No. To the 4th. Plus, let's go with, actually, no, I'm going to go minus. I'll go plus. And then we're going to say, how about 5x squared equals 14. Okay. Well, I got to set this thing equal to 0 if I'm going to solve, right? I'm not going to take out an x squared. I have nowhere to go with that. It's not equal to 0. I can't use my 0 product property. So I'm going to have to set this thing equal to 0. And now I can use sometimes what we refer to as variable substitution, or because this one's a pretty simple version of variable substitution, we usually just go for it and factor as if it were a quadratic. So I'm going to have x squared and x squared. So what multiplies to negative 14 and adds to 5? Well, that would be positive 7 and negative 2. Cool. Now it's in factored form. I can set each individual factor equal to 0. So I'm going to have x squared plus 7 equals 0 and x squared minus 2 equals 0. I'll have x squared equals negative 7, and if I square root on both sides, I get x equals plus or minus I root 7. Hesitated there. Sorry. All right. Now the other one, I'd have x squared equals 2. Square root on both sides, I get x equals plus or minus the square root of 2. I don't know why I rectangled one and I circled the other, but that's where we are at. Okay. That's a long enough video. I'm done with math. I'm tired. I don't want to do any more math right now. I need to rest my brain and, hang out with River Dog Jenny and stuff. So I hope you guys enjoyed. I hope this worked out well. I hope that the video is all synced up. I hope there's no issues or anything like that. Make sure you follow, of course, River Dog Jenny on the gram. Have a wonderful day. Yo, Ro, you only round once. America, freedom, rock and roll, Costco, and River Dog Jenny on the gram. America, see ya.